This is lesson 5.2 part 3. We're going to do example number 2a and b. We had just finished seeing what the role of the h is when you have a form like this, x minus h squared. We saw that it's a horizontal translation of the graph y is equal to x squared. So if we were to ask how these two graphs here are related to y is equal to x squared, well, the simple answer is to look at the form here and realize that you have an h over here. So this graph here, its h is negative 5. So what that means that this graph here is y is equal to x squared translated to the left 5 units. And our vertex, if you want to find the vertex, would simply be negative 5, 0, because it's h, 0. In this situation here, our h is 7. So what that means is this is our graph y is equal to x squared, our parent graph y is equal to x squared, translated to the right 7 units. So if you want to graph, for example, this one over here from your parent function, you would just basically look at every point and move them to the left 5 units. So let's go take a look at x squared and move them 5 units to the left every time. So if we have x squared over here, and I want to do x plus, so if I want to graph y is equal to x plus 5 squared, I'd move this graph, and let's make it a different color here. Let's make it this blue color. I'd move the y is equal to x squared graph to the left for every point. So at 0, 0, I'd move it 1, 2, 3, 4, 5 to the left over here. At negative 1, 1, I'd move it 1, 2, 3, 4, 5 over here. Because at negative 1, I'm at negative 1 here, so to move 5 to the left, it'd have to be at negative 6. Over here at negative 2, I'm up here, so 1, 2, 3, 4, 5 over here. And then same thing over here, 1, 2, 3, 4, 5. Just like that. And then 1, 2, 3, 4, 5, like that. And so I've just shifted every single point over to the left by 5. I'm not moving up or down, so I'm not shifting the y values. I'm shifting the x values specifically. And that's how we would derive it from the parent graph. And again, I'm moving to the left because it's a plus in here, which means our h is actually negative. If it was a negative in here, it means our h is actually positive. Just before we go on to the conclusions for combination translations, I just want to do a quick little clarification about how you would find the value of a in these different forms here. Remember that there's different forms for quadratic relations. So if you had the standard form like this, your value of a would be the number in front of the x squared. If you had your factored form would look like this: ax minus r or s, x minus s, where the s and the r are your zeros. This value here would be your a in the front. You could expand to get back to the standard form and find your a if you needed to as well. And then if you had your vertex form, a x minus h squared plus k, your a is in the front of this bracket over here. So in this example, our a would be 1. In this example, our a would be 1 as well. In our previous video, I had said you could expand to get the standard form and find your a in front of the x squared value. But if you look over here, in front of this bracket, our a is 1 because there's no number there. Same thing over here, our a is 1 because there's no number there. So just a little clarification on finding a. Make sure you know what form you're looking at, and that way you'll know where a is located. So far what we've seen in the past few videos are examples of translations that are either vertical or horizontal. We haven't seen both combined together. But you can actually have a vertex form where you have both types of translations present. So in this example over here, this is our vertex form again, with A being at the front again over here with a bracket. We have our H over here and our K over here. So the H value in this case is going to represent a horizontal translation still, so it's still horizontal. And the K value is going to represent a vertical translation still. So if ever you have a situation like this, now your vertex coordinates are always going to be HK, value of H, K. And your axis of symmetry is going to be X is equal to H, because you can think of this H as controlling where on the x-axis you are. So your axis of symmetry is still going to be X is equal to H. So we're going to do some examples together. We're going to take a look at some formulas, some equations, and take a look at the different values to see, and also see if we can understand how they're related to the parent graph of y is equal to x squared. So here we have y is equal to x plus 4 squared. Let's take a look at our h value. That's inside the bracket here. Remember, it's the opposite sign, so negative 4. Our k value, there's no plus k after, but there actually is, we just don't see it. It's plus 0. So our k value is going to be 0 in this case. And that means our vertex is negative 4, 0. Negative 4, 0. Based on our rules that we saw in the boxes above. So make sure you go look at those rules above. Those are great rules to add to your notes as summaries. So how does this relate to x squared? Is it a shift left, right, up, down? Well, it's not a shift up or down. We don't have a k there, so we know that. We do know that it is a shift either left or right. It's a horizontal shift. And since our h overall is negative, what that means is, sorry, it looks like an equal sign. Let me erase that. What that means is that this is a shift to the left by 4 units. To the left by 4 units. Let's look at this one here. X squared plus 5. Notice that we don't have, this is not x plus 5 squared. It's x squared plus 5. So this is the case where h is 0, because it would look something like this. X plus 0 squared plus 5. And that would be x squared plus 5 simply. Our k would be the plus 5 in this case. And our vertex is going to be 0, k. So 0, 5. Now since there's no h, we know it's not a left to right translation. But since there's a k, we know it is a vertical translation, and it is specifically up by 5. Let's take a look here. Here we have a nice combination one. So we have an h. Our h is positive 2. Remember, change that sign in there. We have a k. Don't change the sign. Our k is positive 3. Our vertex is going to be hk, so 2, 3. Is there a left-right shift? There is, because there's an h. We know it's right 2. Is there a vertical shift? Yes, there's a k. So it's up 3. So if you're making these graphs from your parabola of x squared, you would go in there and move each point to the right by 2, and then up by 3 once you move them to the right. Or up by 3 and right by 2. It doesn't really matter which order you do it in. Let's take a look at this example here. So here we have x plus 1 squared minus 7. Our k value is pretty easy to spot. It's right over here, negative 7. Our h value is pretty easy to spot over here as well. Plus 1, just make sure you switch that sign so it becomes negative 1. So our vertex is negative 1, negative 7. What type of translations do we see? Well, is there a left-right movement? Yes. We're moving to the left by 1. Is there up-down movement? Yes, we're moving down 7. Now we can go back and take a look to make sure this makes sense based on our vertex. Notice how the a in front of here is positive. That means the parabola opens towards the bottom. So if the parabola opens towards the bottom, will it make sense to have a vertex of -4, 0? If you find other points in your graph, you'll see if that makes sense. You can do a quick sketch, identify if you have the right vertex. But as long as you follow the rules and you see the right format, there's no reason why you shouldn't have the right vertex and why you shouldn't have the proper transformations provided. So what we know now is that you can use both forms that we discussed to do a quick sketch of a graph. So a little trick, if you have to do a quick sketch of a graph, as I was getting to there, you can use both of these forms here. Actually, all three forms if you wanted to sketch your graph. You can use the factored form to find where your zeros are and place your zeros. You can use your vertex form to find your vertex. So these are your zeros, R and S. Your vertex, let's say, is over here. That would be HK. And then if you want, you could find your y-intercept, that's C in a standard form. So let's say somewhere over here. Then you could just connect the dots. You don't really even need that y-intercept. You could just really focus on these 3 dots here. So with your zeros and your vertex, you can do a quick sketch and then extend the graph, and you've essentially sketched your parabola with only 3 points using those 2 forms. So nice and easy to sketch, to see the general shape of the graph, to see which graph would belong to which equation if you had to do so in a bit of a hurry. So let's try example 2 here. The following transformations are applied to y is equal to x squared. Determine the values of h and k and write an equation in the vertex form. So the parabola moves to the left 1 unit. If the parabola moves to the left 1 unit, you know you're not dealing with k. So our k is going to be 0 in this case. It moved to the left 1 unit, so that means our h must have been negative, so -1. So what that means is we took our x squared, and we modified it in this way here. We did y is equal to x. It's a horizontal translation, so it's in the brackets, plus 1. I put plus because I know that since I moved to the left, my h must have been negative, so I put the opposite sign in there, squared. Parabola moves up 2 units, so we're not going left or right, so we know we're not dealing with h here, but we are dealing with going up 2 units. So our k value is going to be 2, positive 2, because we moved up 2 units. So we're going to have y is equal to x squared, which is a parent function, and we're going to add plus 2 to move up. Parabola moves right 3 units and down 1 unit. So if it moved right 3 units, we know our h is going to be positive 3. Down 1 unit, so it went down, we're going to have -1. And so if we were going to write this out in our standard, in our vertex form, we would have brackets x minus 3, because our h will be positive when we take it out, squared, and it went down 1 unit, minus 1, just like that. Let's try this example here. You can pause the video and try it yourself. Parabola moves to the left 4 units and up 7 units, so we know k must be 7 because it moved up 7. It moved to the left 4 units, so if it moved to the left, what that means it's h is -4. So if we're writing this in the vertex form, we're going to have y is equal to x plus 4, because when we take it out to write our h, it has to be the opposite sign, squared, don't forget that squared, and then plus 7 since it went up 7 units. So there we just took a look at some descriptions and wrote an equation based on the descriptions by finding our h and k first. In the previous table, we had looked at some equations and provided those descriptions instead. So in the last video, what we're going to do is we're going to sketch the 2 graphs provided here, starting with the graph y is equal to x squared, to show how the parent function or graph is actually transformed with h and k.